Hey guys, and welcome back. This is your very last lesson of Unit 1. So congratulations, you have almost made it to the end. So yesterday we talked about the different types of energy. We talked about thermal energy. And so today we are just going to wrap it up by talking about heat transfer. So we're going to talk about heat transfer today, and then we're going to be officially done with Unit 1. So thermal energy is transferred between objects in 3 different ways, and we have to know all 3. So those 3 ways are conduction, convection, and radiation. So we're going to talk about conduction first. Conduction is when energy is transferred through direct contact. Examples of this would be burning yourself or touching snow. So let's say that you are cooking something on the stove and you have a hot pan, and that pan warms up and you go to move it and you don't realize that the handle is hot. When you touch that handle, it burns your skin. And that heat transfer is directly from the pot to your hand. So that is a direct contact, and that would be conduction. So you have, unfortunately, burned yourself through conduction. So conduction is through direct contact. Next, we have convection. Convection is when energy is transferred through the transfer of fluids. So this is either going to be a liquid or a gas. Examples of this would be convection oven, a heating system, water moving and boiling water. Other good examples, if you guys remember from earth science, would be convection currents in the atmosphere that set up our weather systems, and also convection currents in the mantle that drive plate tectonics. Now, convection currents are density currents, right? So we heat up, so in this example with this guy sitting here in the chair, and then this is a heater, a space heater. It's probably winter time. So what happens is that the heat is released, right? And this is technically through a gas, because this would be through the atmosphere. So the heat rises as this air becomes warm. The molecules become less dense and they rise. And then as they get away from the heat source, they eventually cool down. And as they cool, the molecules become more tightly packed, become more dense, and then sink back down. And it goes in this circular pattern, and that is convection. That is called a convection current. So it's heat transfer through the movement of a fluid. And last but not least, energy is transferred as an electromagnetic wave during radiation. So our last one is radiation, and that is just through the transfer of electromagnetic waves. So this is going to be like visible light and infrared rays. The best example of this is, well, there's a picture of a beach right here, but if you go outside, especially during the summertime, when you step out, immediately you can feel the heat from the sun. That's radiant energy. You don't have to, be standing directly on the sun in order to feel it. What you're feeling is those energy waves that are making its way to the earth, and then we can feel the energy that's coming out. Other examples of radiation would be from like fire or any kind of light source that heats up. That's radiant energy. If you can feel the warmth without actually touching it, those are just the waves that you're feeling, then that is radiation. So this is the difference between conductors and insulators. Conductors, we know that good conductors are metals, right? Because we've talked about metals and nonmetals. And insulators are those that the electron flow is difficult between the atoms. For right now, you actually don't need to know anything about the valence electrons. We haven't talked about the atom yet, so don't even worry about this one. But we just do know that a conductor is a good conductor of electricity. That means the electrons are flowing easily to create a flow of energy. So that's the only difference between conductors and insulators. There is going to be a question on your test about metals and valence electrons, but since we haven't even talked about the atom yet, I'm going to give you guys the answer to that one, so don't even worry about it. Last thing we have to talk about is specific heat, and the specific heat is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So an example here, it says you leave your water bottle in the car in August on a 105 degrees Fahrenheit day. When you go to put your seatbelt in, you burn your hand, yet your water is drinkable. Explain why. The answer here is that metal is a good conductor of heat and electricity, right? So metal is going to heat up very quickly. It has a low specific heat. So the lower the specific heat that you have, the quicker it's going to heat up. Water has a high specific heat. So even the difference between like the sand when you go to the beach on a sunny day, the sand is going to get hot a lot quicker than the water will, because that water has a higher specific heat. It takes more heat and more energy to warm it up. If you have a high specific heat, it also takes you a longer time to cool down as well. So what do we need to know about specific heat? For us right now, all we need to do is be able to look at the value and tell me, okay, this one will heat up the quickest or this one will take the longest to heat up. So if we look at these substances, we have aluminum, olive oil, nickel, and water, and then we have their specific heats in joules per degrees Celsius. So these specific heats, and a joule is just a unit of energy. That's all a joule is. This is just like the density, right? So the higher the number, the higher the specific heat, okay? And the higher the specific heat, the more time it's going to take to get that substance to heat up. So here we have water with a specific heat of 4.18. That will take the longest to heat up. So your water will take the longest to heat up. And then our lowest value here is nickel with 0.444. That's the lowest number. This one will heat up the quickest, which makes sense, right? We know that metals are good conductors of heat and electricity, so metals will heat up quicker. So nickel is a metal, and aluminum is also a metal. So if we take a look at this, they have the lowest specific heats, which means they will heat up the quickest. This also means that they'll lose their heat the quickest as well. So they'll cool off quicker and they'll also heat up quicker versus olive oil and then water, which will take a while to warm up and then also a while to cool down. And that's it. So we need to know the difference between conduction, convection, and radiation. And we also need to know how to identify which substances will heat up quickest or slowest based on their specific heat. As always, if you guys have questions, let me know. And if not, I'll catch you guys in the next one.